are in the need for airplanes. There were expensive long training for pilots in the world wars, so limiting the need for new pilots to be trained, because vehicles are always different, or accident also occurred because the different organization or poor organization of the habitacles. So a great improvement in the study and application of ergonomics was developed on airplanes in the Second World War, and after this also on other vehicles. We also had our first distinction. I mean, you have or not heard this first part of the introduction. We have three main families of ergonomics. So physical, cognitive, and organizational ergonomics. And I go briefly in the definition. So physical is linked to biometrical and dimension and organization of the human body, the internal organs, the manner they work and suffer, the extension and the capability of your joints in the body to move. So you can identify the workplace, the organization of command, the access, the seating, and all the arguments linked simply to the dimension and features, main features of the human body. Okay? Cognitive ergonomics is the manner which the body use the environment, the interface between the human and the machine is important, physical, but you also need to produce a communication between them, so you can understand the external world and make decision and also apply decision to the external world. So you must use your sense, your eyes, your hearing, your touch and smell. If something is cold or warm, and all the things used for introduce recognition for signals, also the other people moving, and all the things needed, for example, for guidance in the traffic. So this is an application for cognitive ergonomics, okay? Finally, the organizational ergonomics. So the manner you can manage more than one only people. So even if you imagine to study an urban context, or a workplace for a teamwork, cooperative work, so realizing optimization for the contemporary use of the environment by several people. Okay, I lost you again.
Yes.
Okay.
No.
It's good now. Okay. Yes, I fear I don't see you in face now, and I don't. So maybe also I lost the communication again. But okay. So first
We
of all,
will tell you if we have lost you.
Pardon me. This is not my my possibility to correct the internet applications. So the applications, you can have a list of them. So the benefits in workplace design, occupational health, safety, product design, all the other things. But the key benefits are the reduction for human fatigue and error can be produced. So you can increase productivity and safety. These names, these terms are not strictly related to economical application, but productivity can be also the performance. If you are racing a car, you can go faster if you have a better ergonomics in your car. This is evident if you imagine also motorcycle riders in racing. They are so linked to their position when they are riding the motorcycle. So the adjustment for the handlebars, the Seat 8 and length, the shape of the tank, the petrol tank is important for driving. Okay, so this is not limited to producing more money. Okay, and all the other things. Less absenteeism, obviously. If you are tired or you are sick by your fatigue from work, you cannot be present at work. Reduce lost time if you have organizational ergonomics applied, etc. Starting from the first part, pardon? Some question? No. Okay. The first part, the physiological, is linked to anthropometrics. So you know what we mean about anthropometry. Simply is measure of the human external body dimension in static and dynamic condition. Static means simply the measure of every single part between the joints, so the thigh, the leg, the ankle, the feet dimension, and the body, the trunk, head, and all the other dimension you can identify for different part of the body and in different positions, so standing, sitting, um, or other postures, as you see, as you can consider. Dynamic anthropometry is linking together both the extension of the and the possible position of the single segments of the human body, so you can reach controls or have access for entering and exit from a vehicle, maybe, and also the effort and forces you can apply in the different position, so you can correctly identify and design a lever on the steering wheel, any kind of object you need to reach and move. Okay, a pedal like this. So this is the standard reference position for a human body to be considered in the anthropometric study. So you know the sagittal plane is dividing into half, left and right part, symmetrical part of the human body. Coronal is dividing front and rear part of the body. Transverse is dividing more or less in the bell part of the body, the upper and lower part. So this is the reference plane when you have definition for this. And we can consider a lot of different approach to the human body. We can also divide the anthropometrics in somatotypes. And so you have the ectomorphs, mesomorphs, and endomorphs. Simply, we can consider this kind of slim, very slim figure here as ectomorphs. The so named Mesomorphs are the normal body, so well balanced, firmed, but no fat or short legs in this manner. The endomorphs are usually associated with a fat people. Okay, very different approach. So imagine the main composition of a population is in this family, the endomorphs, or in the opposite, ectomorphs, makes a different design for seats or dimension for the seat belts or distance between the steering wheel and the tides, because you have the size here of the abdomen, which is very different from this other, and also the extension in the width. Okay. So we have a lot of different dimension, and they are also different in reason of the geographic area, the age, if you are male or female. So you have different databases for North American people, South American people, Asiatic, Europe, and Africa, and a lot of different statistics for this. When you have enough samples for statistic and anthropometric data, you can also identify the percentile. You have idea of the percentile, yes?
Yes,
No.
it's the size. I don't remember the number.
Yeah, okay. Anyway, this is a statistical definition, but easy to identify. So imagine the total number of people you can measure, make 100%. If you take the 100 percentile, this means all the possible dimensions are included in this number. If you take 95 percentile, which is usually the limit, because very few people are in the extreme condition, very, very small or very, very great, and tall or large or other extreme dimensions, but greater. So you use 95 percentile, which means all the possible dimensions are included in this list of dimension. All the other are smaller. Then 95 is the top limit for the dimension. We consider allowing a person, a human body, to sit and reach and enter and exit into our habitacle. In the mid of the distribution, we have the 50 percentile, is the top part. You remember the Gaussian diagram is a kind of bell diagram.
Yes.
Okay, so you know right and left part are very long and asymptotic to the horizontal line. So in this extreme portion of the diagram, you can find very limited number of persons included. In the center part, which is included by between the 5 and 95th percentile, you have the greater amount of people included. So we usually use 5% as the lower dimension of bodies, and 95 as the maximum level of people. So depending of the object you are designing. If you are making a custom car, like a racing car, usually you design the car dedicated to the driver. You measure physically the driver. The seat is only dedicated for this driver. But if you want to go to the market and make a kind of universal adaptation for the habitacle, you must consider the smaller people and the greater people you want to go and use comfortable the car. And these are the lower 5 and the top 95 limit you use. 50 percentile is the higher part of the diagram, in the center part, but this is not used usually because this is anyway a particular median population, which is not representative, not for the smaller, not for the greater. Okay. Biomechanics includes the knowledge of the basic biological features of the human being. So the different application of force, this is a sample for apply a load to our arms, and this is different, the capability to lift or make force depending to the position of your arm, but also from your backbone and legs. This is all linked, so you have a lot of samples and different measures made. So the force are listed usually also in tables, in reference tables, for having a reference value if you are designing pedals, levers, wheels like the steering wheel and something like this. Imagine you must also consider the speed of use of a control, if you have a slow application of a force. Okay, so force is one main input value or factor considered in biomechanics. Joints are important because you need to know the comfortable range of motion for each kind of joint, and also the force you can use in a joint is depending from the position of the joint. Okay, so knowledge of the organization is important, and you have simple joint, compound joint, and complex joint. You have samples here, like simple joint is shoulder, hip joint, so a kind of ball joint. It's similar, is this one for the shoulder. You have a complex joint here, compound joint is radiocarpal joint, is organized by several surfaces and movable parts. And finally, you have the complex joints like knee or articular disc or meniscus. So the more complex is this center part, radiocarpal joint. Complex is because you have knee joint, you see two main parts make contact, but you also need the support of the patella here and the tibia here. This is the piatto tibiale, this part, and this is the perone. I don't know the name in English, but anyway, this is tibia, this is perone, this is femoral part, and this is the rotula or patella in front, limiting the extension. When you go straight, you cannot go in the other direction, okay? Range of motion are also detected and tabulated, and this is a maximum comfortable position for each of them. And so we have an idea of the range of motion. The other thing is physiology, which is linked to the normal function and the good health of the body. So you need to know, mainly these are samples, but the cardiovascular response is the frequency of cardio and the pressure and other things linked to the blood circulation. So in several positions, you have more difficulty for circulation, or you have more work from your heart. Okay, respiratory response. Breathing is linked to the change of oxygen and expulsion for carbon dioxide, but this is also linked for other tables and for giving you an idea for the humidity of the ambient, the amount of fresh air, and so the comfort and the capability to think in and react in the proper way is also linked to and is an important linking to the quantity of fresh air, blood, and oxygen you can have. Okay. Metabolic response. Obviously, this is completely different, the need for oxygen and the work for your cardiac system, depending if you are or not making efforts. Static and dynamic muscle loading. So imagine a dynamic load is a movement. Usually static is more stressing because maybe a continuous standing position, static position for a leg, but you are making a continuous pressure. This is the sample for accelerator, for example. Tissue compression is, for example, you are sitting on your back, and so you have the rear part of your thighs pushing on the seat cushion, and your backbone and your back is on the back of the seat, and you have your weight compressing your tissues, your muscles, so affecting the circulation for blood and also relaxing the tissues is critical. You need always changing position when sitting. It's difficult to remain in the same position for a long time. Okay. So you must investigate all this kind of extension, different position which allows to you to transfer your weight and move, maybe also stepping up here, moving in different positions. They are simply a lot of different conditions sampled in this diagram, but this is for giving to you an idea. The range of motion of the same articulation can change a lot depending on your position. Okay, if you are loaded or unloaded ankle, or hip or other things, you can move also your leg in rotation in a different manner. Okay? Psychology is linked when is concerned with adapting the equipment and environment to the people, because usually people have limited capability to change their physical condition and psychology, pardon me. So you must study the performance of the human psychology, the response to external stimulus, and the efficiency for perception and reaction modes. So you can increase safety, you can reduce the stress because this is easy to recognize the external condition, and make the right decision and apply the decision. Imagine normally you make this all the time in the traffic. Okay. For performing any activity, this is a reminder of my first introduction, human receives various information through different sensory organs. You use always your 5 sensory organs. So eye, ear, nose, tongue, skin, and all this information are used to be interpreted by your brain. You can apply your intention and your decision in the proper way, we hope, and then you can send the information to your muscles and move and make all the action. Okay. Are you still alive?
Yes.
Yes.
I'm very happy. So the automotive ergonomic, we will have some very fast overview, and I really ask to you, if you have more interest to go deeper in the argument, you need to write to me. I will share to you the presentations, and we can also have a follow-up in the next class for a limited time. Okay? Because I know this is an extensive argument, and a lot of science and information are used in ergonomics. So necessarily this is simply an overview. But if you need more information or special application, I wish you will also write and have a discussion with me. Okay. So, speaking in automotive application, we have spatial arrangement, which is linked to biometrical reachability, strength capability, or physiological and metrical, visual feed and visual obstruction, seat design and sitting comfort are also considered. So the first application are measure and dimension inside of the car. First of all, we need to go inside. The driver must reach all the control and move freely to move the controls without any kind of problem or interference with the passenger outside. So the great argument, the highlights are linked to spatial accommodation, which means sitting position, leg room, head clearance, and lateral clearance, sitting comfort and discomfort, reach and limitation for human body, visual field, and visual obstruction. This is an introductory discussion. So the conventional static measure are linked in this way. I prefer to show to you some pictures, some sketch like this. So this is what we mean in reach dimension. Lower arm, upper leg, and we can identify the maximum preferable dimension for the seat length, the seat height, and this is a starting point to imagine to use in the correct way the body dimension. So you can identify the eye height, the seated height, so the clearance up on the head, and so identify the clearance is possible if you know the seated height, shoulder width, knee height, and seat width. So the height and width of the seat are linked to these minimum dimensions usually. And this is basically the discussion. If you imagine what happens when you are driving the car, you need to have no interference between your elbows and the surrounding part of the car. Also, the backrest of your seat can produce problem if you need to move back your elbow. So all these kind of movements reach, this is important in the other end, not only for moving the gear shifting, but also to reach the panel control and switches. So if you have the dashboard not possible to reach without moving the shoulder on the from the backrest, this is not a good condition. The knee clearance under the dashboard, under the crown of the steering wheel, the foot pedal position and travel. You need to have a movement for the ankle and foot included in the comfortable and normal excursion for the joint. And so if you need to accommodate different size of people between maybe 5 and 95 percentile, you need also an adjustment for seat, both in extension, longitudinal extension, because you can have different extension for arms and legs, and also in height, because you always need to see out of the car. So the eye location must be in a limited area positioned. Without this condition, this capability of accommodation, you have a limited visibility. The visibility is also investigated by including the eye and head movement. Is another kind of range extension. You can find also a lot of definition, so conventional definition used in international way to define the main points to be included in the study of the driver and passenger position and reference point. So the H point, all of you use always the H point. this is so famous, is the hip point, is the hip pivot, more or less is the joint between your basin and thigh. Okay, is the midpoint of the line connecting the two hip joints, because we hope you have two legs. Okay, so two hip joints. BOF, ball of foot, is the ball joint of foot. Ball joint is between the fingers and the remaining part of the foot. You know, is in the forward part of the foot, but not the fingers. AHP, accelerator heel point, is the position of the heel while placed on the accelerator. I can have a picture here. So ball of feet is this point where you usually apply a pressure on a pedal. AHP, accelerator each point, means the contact point between the floor and your feet. Okay, and the AH point is the position of the H point. Exactly. So this is a very important diagram. This is a very basic diagram. This is the starting point for all the ergonomic of your car. Depending on your choice, you will always start from these 2 points here, ball of feet and accelerator heel point. So you have also the information of this angle between the ankle and the leg, a comfortable angle between leg and thigh, and you have the position for the H point. So if you want an higher point for the H point, you also must modify all the position, but starting always but from your mechanical position of accelerator pedal. All the other position of the body segments, the trunk, head, and all the other things are limited in a comfortable range and possible physiological range starting from this one. So never answer to my question, what is the starting point for accommodation in the driver position. Never start from the H point, but is the AH point, the heel, accelerator heel point, not the hip point. Okay? You understand?
Yes.
This is a common mistake to confuse this is the starting point. This is defined by this position. So, completing the names, the important names, you have the SRP or the R point, you know, the H point and R point, which is the real position when you load the seat with a weight. So it's depending from the elasticity and the compressibility of the foam of the cushion of the seat. You can only identify when you have a real seat. You load with a mannequin or a ballast, and you can measure the position of the H point, where is really. Neutral, when you have the 50 percentile person selected, so the mid position. The higher position, so the more backward position for the seat, is associated with the taller, the greater sized people, 95 percentile person. And we can have also other letters and symbols identifying different position, but they are the main. Okay. So these are the wide range of target population. We use 5th and 95 percentile anthropometric data. If you want the wider range possible, you use 5th percentile but female population and 95th percentile for male population. Okay, this is the most correct way to use the dimensions table. You have seat track travel limit, but this is depending from the accommodation data you select. But they are also linked to the need of use the pedals and the steering wheel. So you must, if it's possible, move forward and backward and up and down in a manner you can accommodate both the need. So this is the representation of all of the possible position for a sample. Starting from the same accelerator point, you have this kind of inclined line representing the H point moving in the different accommodation from the end to end track of the seat adjustment, and also the percentile. If you can see, this is shadowed. You can see this kind of diagram. These curves are also linked to the percentile. Okay, 90, 95, 95 and a half. And this is the middle position. Okay. Question? Any question?
No.
You are completely comfortable with this?
Yes.
Perfect. So, other things. We can reach the controls. We need to control the leg room, the headroom, and the lateral space. In another presentation, we can afford in detail a sample for tables. My intention in this overview in this moment is give it to you some sample, maybe for headroom. We need to have a minimum 5 centimeter of head clearance for in a vehicle. These are recommendations, so these are from experience. If you start making a draft design, a good starting point is to have this dimension, this clearance. Okay, lateral space, usually if you add a 10% of the 95th percentile dimension of the shoulder width, is considered a good dimension for lateral clearance during normal sitting side to side by side. Okay. Samples. Okay. Other consideration are the dynamic anthropometric, you can see different area swept by the motion of the legs in this sample. They are representing the maximum extension. You can see the extended fingers, so you can touch something in this range without moving your shoulders or a torsion on your body. This is an overlap between the area, but you cannot bring something or use a control in this maximum extension. The normal extension is limited to this continuous line circle, which is meaning you can close your wrist, your hand, grab an object so you can move a control. Finally, you have also a comfortable area, which is this one, which is meaning all the area you can reach also closing your elbow. Okay. So the minimum position is because this dimension, this radius here correspond to the elbow, the lower part of the arm extension. You can extend your arm, you can go till now, move this way simply with a flexion of your arm from the elbow. Okay, so different areas covered by your motion. So for exceptional movement, you can also imagine to use the external area. For normal use, it's preferable to limit to the envelope of the lines, the continuous line. Okay, this is simply for having an idea. This is the head contour, including also hair and the possibility to tilt in front and back your head on the neck. And so this is the need for identify an eye ellipse. The center of your eyes can move in front and rear and also side by side. So you have an area for the center of your eyes, not simply a point. And this volume is including all the possible position for small people. They are usually here in the front of the area because they have the seat in the forward position, and the back is properly for the taller people. Okay. We have also the need to adjust the steering column and steering wheel position if we want completely to accommodate the different sides of people. For having an idea of the different forces allowed for comfortable use of pedals. Brake pedal, we start from the wake people. So the 5% of the right leg strength. In this case, we consider a male, but we also wish to sell cars safely to female people. Okay, but anyway, this is for making the first consideration. These are tabled in our anthropometric tables, statistical tables. So 261 Newton, which means more or less 26 kilograms of maximum force. This is for a limited time, so you can use this value also for referring the kind of force you can allow on the pedal. So all the braking system and assistance and the dimension for the pedal, you must design according to realize this level. Okay. A clutch pedal. This is frequently operated compared to the brake pedal. Pardon me for the error in the orthography here, but you use several times for also for a long pressure. If you are in the traffic, you are adjusting and modulating the use of the clutch in maneuvers for parking and something like this, and shifting. You are continuously using this pedal. So you have on the left leg the maximum effort allowed, the maximum force is less than the right, usually is more or less 24 kilograms and a half, but we must reduce in reason of reducing the stress for this leg, and so we consider only an half of the maximum force, and so we limit this kind of load to 123 only newtons. This is the kind of consideration you can use. For an accelerator pedal, which is a static effort, you have all the time your accelerator pedal pressed. So starting from this effort for a long time, so not for a single dab, but for a continuous pressure, you must limit to 163 Newton. But for the reason of allowing also aging people, not introducing pain and other things, we must limit to 1/3, 30%. And so the maximum limit we use is this number, which is more or less 5 kilograms of pressure. This is the maximum allowed standard pressure on an accelerator pedal. But we need also to support the leg, because you also have your weight of your leg pressing automatically on the pedal. So you need a counter reaction for the control. If you have not, simply you have always a completely pressed pedal to the floor, so maximum accelerator actuated, even if you have no force or weight on it. So we need a minimum level of reaction in reason of a 9% of the body weight part, and making the calculation, we have a 24 Newton of minimum level of spring force on the pedal. Okay? I don't know if you are familiar with this kind of consideration, but they are all included in the studies for the controls. They are simply here listed because for every kind of control, knobs, gear shifting, and other things, we can find similar discussion. So this is the steering wheel. In the past, we had no power assistance for steering, so if you had a heavy track, you needed also a very strong driver for steering. But in actual and today products, we have power systems, so the limit we can set in this in this range. So the weaker driver are in limit of 36 Newton meters with both hands, and this is the force related to this kind of diameter with lever arm of dot 21 meter. So imagine a standard diameter for a steering wheel. Frequently operated, we can also reduce this limit of 161 is 51. Maximum actuating force for steering wheel should be less than 51 Newton, so 5 kilograms of maximum effort. Okay. The gear selection, same kind of arguments, limit to 5 kilograms the maximum effort for changing gear. Okay. Visual field, we have a limit for it. And you can imagine you have two eyes, both have movement, lateral movement. If you are pointing straight in front of you, you have overlap between the two fields, which is only limited by your nose in between. So you have not completely your left eye cannot watch completely to the right, and so the right to the left. You have this kind of empty part from one, and you have no binocular field. You must turn your head. The same in a vertical plane. Without moving your head, you can turn your eyes up and down in terms of 45 degrees in the top upward, and downward 65. You can see your lower part of your eyes. You can see.
Yes.
Comfortable is only 50 degrees up and down to the center line. You must add 30 degrees of head tilt. Okay. And so this is the easy tilt up and down. So you can add the extension to the eyes for having the idea of the extension of the center line. These angles are needed for we have different capability to identify the details and define speed and direction and dimension for the object. So the direct view is mainly accurated. We are speaking in terms of physiological features of the eyes in a very restricted conical field, more or less 5 degrees of opening this cone. And so pointing in one direction with your eyes has a very limited area of perfectly defined and identified distance, dimension, the speed you are approaching or the object is moving in one direction, side by side or towards you. All the other fields are decreasing in definition. So the lateral view, the side view, you can only identify something is happening, but you cannot identify perfectly the shape. You can identify more or less color, but you have no idea of the dimension, the speed, or other things. You simply have the attention something is in your visual file, but if you want to detect and identify, you must turn your head and point. Okay. All the other things are more or less redundant for this. I prefer to give to you an idea of the perception and reaction, so cognitive ergonomics, because I imagine the physiological one, okay, to be complete, I will also share to you this presentation, which is standard for engineering studies. And so you will have the packaging starting from anthropometrics. Okay. You will have a definition for hints of physiology, so you will have a great attention to the main part of our body, which is the backbone, which is extensively illustrated also in the meaning for shape, organization, and also the possibility for stress, because you need to identify what it means to have the bones and the intervertebral discs and the organization for them. So you have problems for the angles included by the single vertebra, because you can risk to pitch the intervertebral discs, which are allowing the movement of the backbone. So you have limit in torsion and mainly in this kind of bending of the single segments, and they are responsible for the transmission of the weight load of the body to the lower part of the body, and allowing the comfort or not, and also the correct function for the legs and other nervous transmission on the parts. You can have pain and other great problems for standing for a long time in a position, like a driver, because you stand for a long time in the same position. You will find in this presentation the typical angles allowed for every single joint. The name for the joints are listed in conventional names here, and here you can have them in a sketch, the same names. You must also include in the physiological effect the vibrations, because we are now listing a lot of arguments in static and dynamic condition, but one great argument in dynamic comfort and fatigue is linked to vibration, which are so studied and also solved by the noise and vibrational harshness. You know, this is a great argument in developing a car. So you have low frequency, high frequency, high intensity and low intensity vibration. All of them includes some different things. So imagine a low frequency movement can introduce disease. You have some problems like if you are going on the sea on a boat on waves, you can have disease from them, or rolling, braking in this manner, or accelerating is introducing some problems for passengers, maybe usually. fast movements are bumps and other things. So suspension are deputed to introduce, and also seats are deputed to introduce some filter limiting the exposition to the main forces in a vertical manner. And finally, the high frequency vibration, which are produced by the tires and wheels rolling on the road and the engine and transmission. So these kind of problems are disturbing because they are more or less in the same range of the organs, the internal organs capability to vibrate in the same, in resonance with this kind of frequencies. So they can also create problems to the internal organs. Okay, so a great part of the study is also deputed to identify in these comfort diagrams. You can identify some relation between the intensity and the frequency. So this is the energy associated with the vibrations, and this is the frequency. And you can find safety or unsafety or uncomfortable areas for applications. Okay. I'm confusing you a lot, I think.
No.
Okay, this is only for having an information. All these kind of things exist and must also be considered when you are designing a car. With the obviously you will have specialists for every kind of this aspect, but if you have an idea of they are included in packaging and defining a car, this is also allowing you to start with a more perfect design. Okay. The mannequins for interior packaging are representing, you will find in this presentation also the discussion about the difference between different populations. So I prefer to show you similar. Okay, this is a typical table for reference for dimensions. So you can find all these typical measures referred to the minimum, medium, and maximum size considered in the statistic. Okay, so this is the meaning. If you design a seat accommodation, a driver accommodation for a 95th percentile, this means all the people which are less than 185 centimeter tall can sit and have clearance. Maybe they don't reach if the controls, the steering wheels and pedals, if you cannot leave them to adjust the seat, but all the people in this dimension can sit and use the car. Okay, and this is the fifth, which is the minimum dimension included in our adjustments. And so you will have also shoulder height, knee cap, crotch, and shoulder functional reach is the extension of the arm, and all the other dimension. Okay, foot length, foot breadth, and palm. Really, you have all the possible parts of the body measured and listed, also the weight. But the main thing is a dedicated particular table. The statistic of this table is referred only to male population of the United States, so North America. Okay? The dimension change in this other table, which is dedicated to female population in the United States. So you can identify 95th percentile is only 170 centimeter of maximum. stature. Okay, so depending on the table you are considering, you can refer different dimension. Another great mistake, but basic knowledge, is this two-dimensional mannequin. This is for basic drawing. You only consider this kind of sketch here. You know, they are all conventional engineering instruments for design. The particularity is you have no head, you don't consider arms. This is simply to identify the hip position starting from the pedal, accelerator pedal position. The strange thing is you can change the leg length, the tight length, but the trunk dimension is fixed. It's the maximum percentile allowable. The foot dimension is the maximum foot possible. So you can have also short people, but with enormous feet and long trunk, because they are not changing in this mannequin. Okay, this is only for starting. Now all people use software packaging, so this is not so more used. But if you are driving by a card, a normal paper and pencil, you can use this kind of drawing, conventional drawing. You have all the prescription and instruction for design, all the necessary drawings for packaging. Okay.
Yes.
Okay. So only for having our final idea, and we will spend some more word for better illustrating the other things linked to the access, exit, and the mechanical constraints linked to identify the starting position for packaging, and then adding the seat inclination, the pressure distribution on the seats, the following rows. If you have not only the front driver and passenger, but you have also a back row and maybe a third row on following, then they will all included in the previous presentation. The component for cognitive ergonomics are linked to the performance of the driver. And so you can define the environment, so the infrastructure. If you are imagining to design an highway, a street, you must also identify by this kind of ergonomic the lane width. You must identify as a driver location of the traffic controls devices, so signals, lights, and other things. You must identify the speed limits and other things. Are other people and components on highway? You must understand the other pedestrian, other vehicles, and identify the kind of vehicles, so heavy trucks, passengers, buses, bikes, other things. You must also identify changing between ages. So you, speaking in USA terms or other population. In Italy, we have a lower limit of 80, but in other In other countries, they start to drive cars from 16. So 16 to 18 years old, this is the range, which means different mental and physical states. And so you have different sight and hearing capability, but this means also a different experience. Okay. We are wasting our pardon for the time wasted in the previous part of the lesson of the class by the problem for connection. But anyway, there is another thing strictly related to the organization of the car and the road. So the time variable. The human and machine environment, this is very interesting and important also for you, is linked to the decision process and the realization of adapting the driving of the car to this perception and reaction time. So we can have different conditions in the same person and the same vehicle and same road, depending from its condition, how much time this person is driving, and other things linked to fatigue. And also in years, you can a kind of loss in performance simply because you are aging, or you are boring because this is always the same routine. Performance in traffic. Pardon, I go fast to the visual reception, simply for showing to you what we mean about the cone of vision. So you can see this very, very narrow angle for the center line of vision is simply 3 degrees of complete of opening. You can go to 5 degrees, so 10 of total opening for peripheral view. What happened? Where is my diagram? Okay, this is representing from your windscreen what is corresponding to your main visual. So in the number 3, you have the maximum concentration of information. So the limited cone. In this circular area, you have a good peripheral field of vision. So you have all the information of there is something moving in your visual field. You can have idea of rotation, translation, and also a main idea of the dimension. The outer part, background, is in the binocular field, not completely used, but in front of you. You have an idea of you have buildings, you have mountains, you have trees surrounding your scenario, but no information of details. Okay, if something happening, maybe it is catching your attention, you turn your head and fixing in this direction, you can identify and have more details. Other things important is some color combination and dimension and symbols are more catching your attention, is easier to understand. The dimension of lettering is important depending from the visual ability of a lot of people. So no full vision every time, but you consider also some short sight people. But this is more linked to the speed allowed on the road. So imagine if you are in a urban traffic, urban road, you are allowed to go simply to 50 kilometers per hour. So if you need 1 or 2 seconds to identify a signal on the road and you want to read and understand the message, you have a distance corresponding to 50 kilometers per hour. So the dimension of the lettering is one kind. The same message listed on an highway for 130 kilometers per hour, you need to start in the same time, 2 seconds, to identify the signals and understand the lettering and identify the message. So you need a very greater distance from between you and the signals, the panel, and so you need more increased size for lettering. Okay, so this is the intention to introduce to you this kind of thing. So you have also some interesting details about glare vision, which means the capability to have a clear vision under different lights or passing from dark to brightness and reverse. Okay, this is interesting to consider. Research has shown the time to recover from dark to light condition is between 3 to 6 seconds. Is 3 seconds, and 6 going from light to dark condition. Times is different from young people or skilled people, but imagine this is the normal condition if you are on a sunny day with a bright light. If you enter into a tunnel in the highway, so you go from light to dark condition. If you have no the headlamp in front of you working, you need 6 seconds to adapt your vision and identify the details. So 6 seconds at 100 kilometers per hour means more or less 240 meters of distance. So you can crash anyway and everything is in the tunnel. 3 seconds when you go out from completely dark to sunlight. So another 100 meters at 130 kilometers per hour. Okay. So this is the reason of the lighting inside of the tunnel, which are also gradually decreasing in intensity from the entrance to the center part and then increasing again at the exit. Okay. So the other thing is linked always to the same thing, but have 2 minutes for this. Perception reaction process is this kind of process. So you have something appearing in your perception visual field. You must identify the vision is transmitted to your brain. You have a detection and comparison with all is similar in your database, in your brain. So you identify what is in front. This is a deer. So you can also associate a size for the object or the animal or other things. And you must identify also the direction and the speed of the movement. This is the perception and cognition. So you have an emotional reaction. If you have no panic, you start to identify the strategy. What is the most successful strategy I can activate? I can steer and change lane. I can accelerate and pass before the deer. I need to brake. And also you evaluate the success. What happens if I change lane, but also the deer change direction? I have a crash at high speed, and more I am changing lane, so I have an unstable condition for the vehicle, and I risk also to go out of the road. If I accelerate, okay, I pass before, but even if I have no the chance or is unsuccessfully maneuver, I have a crash at high speed. So great damage, great consequences. If I brake, maybe this is not enough to avoid the hitting, but anyway, I reduce the speed and the consequences. So I decide this is better stop. Until this moment, I had not actuated any pressure or action on the brake. I need a time statistically which is included between 1/2 of a second to 7 seconds for aged people and panic reaction. Okay? At the end of this 7 seconds, simply you start press on the pedal. Foot begins to hit brake, no actual deceleration. So the deceleration and the stop distance start after from 1/2 to 7 seconds of full speed travel. So if you imagine what happens in night time, you only see the front headlight clearance distance. So maybe included in 100 meters usually. And 100 meters is the distance you usually have 2 seconds of time at 100 kilometers per hour to cover 100 meters. So if you need 1 second simply to have your perception reaction time, then start to press your pedal, you only remain 50 meters to stop. If you need more time, you simply crash. Okay? Are you still alive?
Yes.
Okay. So pardon me for the extension of time and the loss of time at starting our discussion for tonight. We have